So what I want to do today is just to spend the time going over what the machine learning is and what we are going to focus and the logics for the class. This is SeungryongKim. I'm an instructor for this course. I'm an assistant professor in Department of Computer Science and Engineering. I'm personally working in machine learning and computer vision field. I'm really excited about teaching this class and studying with you. Okay, so let me start with my brief introduction. I joined the Korea University in March this year. Now I'm a director of the Computer Vision Lab in Korea University. Before joining Korea University, I was the postdoctoral researcher in School of Computer and Communication Science at EPFL in Switzerland. I got bachelor and PhD degrees at Yonsei University 2012 and 2018, respectively. Our main research interest 2D and 3D computer vision or visual understanding, multimodal learning, and deep feature representation learning. Okay, so before starting, let's think about the terminology. So what is the artificial intelligence? And what is the machine learning? And what is the deep learning? And what is the relationship between deep learning, machine learning, and artificial intelligence? Actually, the title of this course is machine learning application, right? So this figure shows the hierarchy of these three kinds of terms. Even though deep learning breaks through the AI boom very recently, about 2012, early intelligence, artificial intelligence still excitement in early 1950. So what is the artificial intelligence? The artificial intelligence, or just called the AI, is a science like the mathematics or the biology. It studies the way to build the intelligence programs and machines that can creatively solve the problem, which has always been considered a human prerogative. Then, what is machine learning? Actually, the machine learning is a subset of the artificial intelligence, and it provides the system the ability to automatically learn and improve from the experience without being explicitly programmed. So in machine learning, there are different algorithms. For example, soft vector machine, or random forest neural network, something like that, that helps to solve the problem. Then, what is the deep learning? Actually, this course will focus on deep learning. So deep learning is a subset of the machine learning, which was a subset of the artificial intelligence, right? So which use the neural network to analyze the different factors with a structure that is similar to the human neural system. So in this course, we will mainly focus on the deep learning, of course, especially fundamentals of the deep learning and its training technique. But as you can see this figure, to deeply understand the deep learning, we have to build the concrete background of the machine learning first. So in this course, we will focus on, we will first start from the fundamentals of the machine learning and then go deep dive to the deep learning. Okay. Okay, so I'm not sure how many of you are working in the machine learning or the artificial intelligence or the deep learning research area, but I guess most of you are working in the related topics, right? So as you know, we are now living in the artificial intelligence world, right? So the artificial intelligence starts to change almost everything in our life. Here are some relevant news or the graph or the figure that represent the explosive growth and impact of the AI. Here are the figures representing the number of the attendance at AI conferences, such as the CVPR, AAA, NeurIPS, or the ICML, which are one of the most prominent conferences in this field. And startup development developing AI system and the enterprise application in AI revenue. This whole statistics definitely show that the recent AI's explosive growth and impact. Professor Andrew Young, one of the prominent artificial intelligence expert or the researcher, compares AI to the electricity. He said, AI is the new electricity. As you know very well, electricity has once transformed the countless industry. For example, transportation, manufacturing, healthcare, communication, and more, right? So similarly, AI will now bring about equally big transformation. Okay, then why now? Why now? As we discussed at the beginning, the starting of the deep learning, start of the artificial intelligence or AI was about 1950, right? But very recently, there were three kinds of the things that become basis of such an explosion of the AI or the deep learning. So first thing is the computation. The second thing is the algorithm. The third one is data. First of all, with the recent revolutionary development, the computing hardware such as the GPU, you can now process a large-scale algorithm in the reasonable computational time. I think most of you have experience on the deep learning or the large-scale neural networks. So you might know it require or it demands so many computational memory and computation time, right? But by using the high capacity computational modules such as the Titan or the GTX Ti GPU, now we can process such a large scale algorithm in a reasonable time, which make a big explosion of the AI. Another thing is the algorithm. There are revolutionary deep learning algorithms that dramatically improve the best performing method, which accelerate the deep learning success. As you can see here is the one very interesting challenge, just called the ImageNet challenge. In ImageNet challenge, we are trying to solve the large scale visual recognition problem, especially for the image classification problem. Before 2012, there were methods to solve the image classification problem, but most of the previous methods based on the handcraft model, such as the handcraft feature descriptor or the handcraft machine learning classifier, something like that. However, at 2012, there were very big explosion by the AAA602 algorithm. I will explain this one briefly in the later, but AAA602 algorithm was the first time deep neural network algorithm that make a high improvement in the image classification problem. After that, so many papers published based on this AAA602, such as the GoogleNet or the LessNet or the DanceNet or the other things after this one. But it was the first time evolution in the computer vision field to make a deep learning explosion. Third one is the data set. We will discuss this one soon, but training the deep learning or the neural network demands a large scale data as well. And there was such a data very recently. For example, WorldNet by Professor George Miller, and ImageNet by the Li Fei, who is the professor at Stanford University. Anyway, the ImageNet dataset were used for computation of the image classification. They have the 22,000 categories and 15 million images. It's very huge, right? So by using this kind of data and algorithm and the computing hardware, now we can make our new model in a reasonable time. Okay, so that's why there are big evolution in deep learning very recently. Thanks for this kind of success, we are now living in the artificial intelligence world, right? So deep learning or the artificial intelligence can be applied to so many applications, such as the virtual assistants or social media or transportation or financial service or the healthcare and e-commerce, something like that. One of the most popular application is the computer vision that deal with the image data, such as the astronomy, face recognition, or the 2D and 3D medical image, OCR, or self-driving car, or the surveillance CCTV thing, something like that. They are all using the image data as input and use the machine learning or deep learning to understand the data. So this course will more focus on the computer vision application. But there's another very interesting application, just called the natural language processing or NLP. In natural language processing, they deal with the text information or the text data, such as the text understanding and text generation, and the spam detection or the user content or the medical text and the machine translation, something like that. For example, in Google Translator, which is one of the most popularly used, the web page, right? So the Google Translator's site or web page use the benefit from the machine translation based on the deep neural network. Another thing is the medical data. Recently, there are many reports or the research about COVID-19, and some of these papers try to understand the patterns of by using the machine learning and the deep learning technique. Oh, wait a minute, there are. Oh, can you see this screen, right? Okay, so let's keep going. Okay, so another very interesting applications, audio and multimodal data, such as the hearing aid, voice recognition, automatic translation, limb reading, or the video analysis, something like that. Numerical or sense data such as the CERN, astronomy, fitness tracker, weather forecast, robotics, or Kinect, also benefit from the machine learning and deep learning stuff. Games or simulations such as AlphaGo, very popular example. Finally, we can do many things with the internet data using machine learning or the deep learning technique recently, right? Then what exactly is machine learning? People keep going. I will reconnect the screen. Okay, so can you see now? Okay, so let's keep going. Okay, so then what exactly is machine learning? What exactly is machine learning? So the objective or goal of the machine learning is to find out the mapping function between the input and desirable output. Here are some examples, such as the speech recognition, handwritten recognition, or the weather forecast, or the play video games, right? For example, if you see the weather forecast example, as a human like us, we can easily expect the Saturday's weather from the given Thursday's weather, right? Why? Why? Because the um, because the we are we have shown the, we have seen the many training data between the input Thursday's weather and output Saturday's weather, right? So based on this prior training data, we can expect the Saturday's weather, our desirable output, right? And another example is the handwritten recognition. As a human, we can easily expect the number of this image, right? Why? Because we have a prior knowledge between this image input and the output number, right? So this is called the training data. So the goal of the machine learning is to find out the mapping function between our input data and desirable output data. Then the machine learning framework formally consists of the two pages, the training page and testing page. In the training page, given a training data consisting of the input and output, for example, X and Y, in a supervised manner, we want to pick the best function F among the hypothesis function set or the model set. This is the training procedure. And the testing procedure, we have to find out the output given the input query data by using the best function F. Okay, so this is the testing procedure. In this course, we will try to study almost everything within this framework, especially within the deep learning framework. Okay, so before keep going, do you have any question so far? If not, keep going. So, in addition, in later this course, we'll cover the computer vision application. One of the most important and interesting application, in my opinion, which benefit from the relevant of the advent of the deep learning. So, what is computer vision? What is computer vision? It is the science and technology of the machine that see and understand as a human being does. So, for example, if we see this image, like this one, as a human, we can easily understand there is the car, there is the building, and there is the traffic sign here, and there are four car objects with their corresponding 3D 3D configuration, something like that. We can easily do that, right? But how can we train the computer or the machine to do similar things like us? This is here is another example. When you see this figure, you can easily say that it is the Eiffel Tower, right? Because we have so many experience of the input this image and the output Eiffel Tower, right? Then, but how does the computer look this figure? Actually, it is just RGB digital information, right? So the question is how to make the computer recognize that this is the Eiffel Tower. So this is the ultimate goal of the computer vision or the image processing things. The computer vision is closely related to the many other disciplines such as the engineering or the mathematics or the computer science, psychology, biology, and physics, something like that. So I know most of you from the computer science department, but some of you are also from the other department, something like the, what's that? Something like the mathematics field or the mathematics department or the electrical engineering department, right? So that's why you are here, because the machine learning and deep learning and computer visions are getting closely related to each other nowadays. So, for example, with computer vision, you can solve the 3D reconstruction problem, which is one of the most important issues in computer vision application, where the machine reconstruct the real 3D space from the partially projected 2D images. As you can see here, we are living in the 3D space, right? But when you see the 2D images, which are projected images from the real 3D data, when we want to solve some kind of computer vision application, we have to, or we can benefit from the 3D information from the 2D image, but it's really a challenging problem. So in 3D construction technique, method or approaches to reconstruct the 3D information from the partially projected 2D image. So here are some examples of the indoor and outdoor reconstruction by computer vision technique. The left bottom represents the indoor reconstruction result by using the computer vision technique. The right bottom represents the outdoor reconstruction by using the computer vision 3D reconstruction method. And here are another very interesting paper that reconstruct the human body. So as you can see here from this single image, as a human, we can easily expect the 3D shape information from this single image, but it would be really challenging task for the computer, right? So nowadays, by using the deep neural network, we can successfully reconstruct the 3D information from these kinds of images. I want to show some examples. So yeah, actually this paper, yeah, here's things. So as you can see here, by using the very recent method, we can reconstruct the 3D information, something like this one, from only single image, something like this. So yeah, it will be amazing, right? And here are another examples here. So by using the single image video, we can reconstruct the 3D shape information with the texture information, something like that. So yeah. So this is very recent paper, accepted in the CBPR this year, right? And there is another very interesting paper here. So by using the deep neural network, we can reconstruct these kinds of the 3D information only from the single image, like this. So we can reconstruct the motorbike or the bird or the car or the shoes, something like that. We can reconstruct occluded part from this image, because we can only have the projected image in here, but by using the deep neural network, we can reconstruct the partially occluded region. And there is another very interesting paper. In this paper, they reconstruct 3D paste from given only single data. When I see this one. So yeah, here. So by using the single input image, this method can reconstruct the 3D information like that. And we can also change the writing condition, something like this. It was the original, and it was the rewriting result, something like that. We can also our data. For example, let's use my case here. Actually, it's not a real time, but here's the thing. So with a single image, the current state-of-the-art method can reconstruct 3D information, something like this. And we can make a different rewriting here with geometry. Okay, let's go back to slide. Anyway, computer vision also enables the understanding the humans, for example, identification or the human pose or the 3D shape, something like that. This kind of information can be used to understand the humans in the robot or the surveillance CCTV camera, something like that. Here. What else? Here is the interesting another application where machine can detect the human faces, even extremely tiny one, by using the deep learning and deep neural network. So as you can see here, this part, it would be really challenging for us to detect such a tiny faces, right? But by using the recent method, we can successfully detect the human faces. Here's another example that segment each instance in the single image. For example, where's that? Yeah, person here with a different person here and the car or the traffic sign, something like that. Then by using the deep neural network, we can easily segment each instance in the given image. Another examples are image generation. So as you can see here, this image is not real image. Actually, this image is a generated image, which does not exist in real world, but it looks so realistic, right? So by using the deep neural network or the generative adversarial network model, which will be discussed in our later lecture, but nowadays we can generate or we can make so realistic images, something like this. What else? There is one another application that's called the image translation. So given this label map, so this label map represents the skies are here, and there's a human things here, and what's that? Yeah, there is a tree, something like that. Then by using the image translation network, we can generate the realistic image, something like this. So this reconstructed image so similar to the ground truth one, right? So I want to show you the examples. So yeah, this one.
Our interactive application looks like a simple paint app. However, instead of color palette, we have semantic palette. Let's pick a label and use the.
So as you can see here,
or cloud will be nice.
By manipulating the label map. Okay, let's turn on the audio. So by manipulating the label map, this method can generate the realistic image in real time. Something like this. So they can change the even style or the label map here. So this is very interesting things. Another application is the image manipulation. where we can manipulate the original image here by using the deep neural network. For example, age of the human here, or the eyeglasses, and or gender, or the pose, something like this. So this whole kind of result are generated from this single image. So by using the deep neural network, we can manipulate such an image, something like that. Here, yeah, here is the here's the example. So by using the GAN method, they can change the pose or the expression here, or the eyeglass with and without, or the transforming the input image to the output image, something like this. And another application is the image illustration problem. For example, colorization. As you can see here, when we have the very old image, when there is only grayscale camera, we might only have the grayscale image, right? Now, what I want to do is to recover the color information from this grayscale image with aid of the deep learning technique. So this is also very interesting application. As you can see here, by using this method, they generate or they reconstruct the color information from the grayscale image without seeing the real ground truth color information. Another interesting thing is the image super resolution. So as you can see, left-hand side, there is the low resolution image perspective. It will be very challenging low resolution. Then by using the state-of-the-art super resolution method, they can generate the very realistic information or the pace, something like this. I want to show the examples. Yeah. So given this input image, this method can generate the realistic super resolved images, something like that. So this is sort of very interesting application of the computer vision for the image illustration problem. Okay. Finally, computer vision can be incorporated with the other application, for example, natural language processing. So you can build a machine that describes the images as a caption, as you can see here. So from the single input image, the network can describe these images, something like this one. The voice is eating, the right foot of the teddy bear, the hair is brown, something like this. So we can build a machine that describe the image as a caption or communicate each other with one image, something like this. Here is another example of the image captioning from the single image. So as you can see here, machine can describe this image as a natural language, something like this. So this is attention map from this caption. Anyway, so this is the image captioning application. So in this course, we'll talk about the deep learning and computer vision. So do you have any questions so far? Okay, so let's continue. So in this course, we will talk about the deep learning and computer vision application. It mainly consists of two parts. In part one, we are going to define and understand the fundamentals of the machine learning and deep learning and their training technique. It might take 7 or 8 weeks, maybe. Then in the second part, we will learn selected topics in computer vision applications, such as 3D computer vision and visual understanding and image generation, something like that. So Yeah, so this is the general course information. My office is a science library building here. The office hours as follows. You can come anytime you want, but please let me know before you coming. And the lecture will use the live Zoom platform like today. We are supposed to regularly meet on Thursday between 2 to the 4:20, right? All the materials of this course will be uploaded at the lecture note tab in Blackboard. And this live Zoom link will be also found at the lecture room tab. And all lectures will record it and upload it to our YouTube channel. So if you have any question, so you can use the Q&A tab or the raise your hand. No, not raise your hand. Turn on your microphone and just let me know. Okay. So this is the tentative course schedule. So today is the first week. So from the next week, we are going to talk about the linear regression and logistic regression, learning theory, something like that, which are the fundamentals of the machine learning. Then we will start to introduction to deep learning and neural network and background and convolution neural network, training the neural network and the CNN architecture. And the second part, we will more focus on the computer vision application, selected topics in computer vision application. We are going to talk about the 3D computer vision here and visual understanding and image generation, image illustration, and yeah. And then there will be the final exam at the end of this course, which might be offline exam, but it will depend on the situation at the time. Okay. Then, as I mentioned as I mentioned at beginning, we don't have any project or the implementation. So in this course, we will take a short quiz. There will be the 7 short quiz aiming to check the understanding of each topic or the computer vision topics in the high level. And following courses, okay, so there is there was question. Okay, so I will distribute the quiz set at the Blackboard, and then you can answer yourself by hand, and you have to submit the answer sheet at the Blackboard site. Okay. Okay, so following courses are relevant to this course, but not mandatory. For example, linear algebra, basic probability, and the statistic, machine learning, deep learning, things, and most of the first part materials will be based on our previous lecture, AAA619 pattern recognition, the last semester class. You can find the previous recorded lectures and the lecture slides in here. So you can, I strongly suggest you study yourself to build your machine learning background and some kinds of the fundamentals of deep learning. So yeah, there is the question. Okay, so I will briefly I will briefly let you know the grading policy of this class later, and maybe not. I would like to give you a few days to answer the quiz. Okay. Okay. So, is there any other question? Okay, let's point. In this course, no book is mandatory. Nevertheless, the following books contain the part relevant to this course, something like the linear algebra and the learning from the data by Gilbert Strain, who is the most prominent professor in the linear algebra, field, and deep learning by Ian Goodfellow, and the mathematics of the deep learning by Roth, and dive into deep learning by the Zhang. So you can freely access these three kinds of the book in the web. So I well know you how much you are busy because you are a graduate student, right? But I strongly suggest you take your time, take your time to make your background on the machine learning and deep learning, something like that. So I strongly suggest you take your time to study these kinds of the books. But in this class, no book is mandatory. Okay. And yeah, this is the maybe last page. This is the grading policy of this course. We will get the 30% point with the short quiz and 55% point with the final exam, which will be the offline exam, will be announced soon, and 5% point with the class participation. Actually, we won't check your attendance every day, but I strongly suggest you try to attend every class. So which will be definitely helpful for your further research. Okay, so but there's no determined rule there's no determined rule for the class participation yet. So I will let you know soon. And there's no project and there's no exam. There's only final exam in this course. Okay, so this is the end of today's lecture. Again, I'm really excited about teaching this class and studying the deep learning and computer vision with you. I hope you also really enjoy this course and learn something from this course and the basic concepts of the deep learning, something like that. So if I take 1 minute in Korean, 이제 이 강의에서는 대부분의 이제 첫 번째 파트가 딥러닝 또 머신러닝의 이제 기초를 다룰 거고, 이제 뒤 파트가 이제 컴퓨터 비전 관련된 셀렉트 페이퍼들에 대해서 좀 세미나 형식으로 제가 진행을 할 예정입니다. 세미나 또는 튜토리얼 형식으로 진행을 할 건데, 이제 많은 지금 들어오신 분들이 거의 지금 100명 가까이 들어와 있는데, 사실 컴퓨터 비전을 공부하시는 분들도 있을 거고, 뭐 다른 머신러닝을 공부하시는 분도 있겠죠. 뭐 예를 들어서 뭐 NLP를 하시는 분들도 있을 거고, 아니면 순수 데이터 마이닝을 하시는 분들도 있을 거고, 다양한 파트에서 지금 이 수업을 듣고 있을 거고, 물론 완전 머신러닝 자체를 사실 처음 해보고자 하는 분들도 아마 계실 거예요. 근데 제가 이제 이 수업에서 얻어갔으면 하는 거는, 사실 여러분들이 이 컴퓨터 비전 관련된 어플리케이션들을 배워서 사실 정말로 내가 지금 연구하고 있는 곳에 사실 쓸 수는 없을 거예요, 바로. 그렇죠? 왜냐면 우리는 정해진 시간에 이 수많은 논문들을 다루고 수많은 테크닉들을 다룰 것이기 때문에. 하지만 여러분들이 이 수업을 잘 들으면 사실 컴퓨터 비전에서 발명되고 개발된 최신 방법들이 어떻게 발명되어 왔는지, 이 프로세스, 어떤 이 뭐랄까 연구가 해왔던 흐름을 이해를 한다면 여러분이 하시는 필드에서도 이러한 방향으로 연구를 진행할 수가 있겠구나, 또는 이러한 로스 펑션, 이러한 네트워크 자체를 내가 하는 곳에 가져와 볼 수 있겠구나 하는 거를 여러분들이 배울 수 있을 거라고 확신합니다. 물론 또 다른 측면에서는 사실 여러분들이 지금 하고 있는 연구들, 여러분들이 대학원생으로 하고 있는 연구들을 사실 평생 할 수 있다고 사실 아무도 보장할 수가 없겠죠. 여러분들이 뭐 갑자기 NLP를 하다가 갑자기 졸업하고 컴퓨터 비전 할 수도 있는 거고, 반대로 컴퓨터 비전 하다가 갑자기 NLP를 할 수도 있는 거고, 그렇습니다. 그렇기 때문에 이렇게 컴퓨터 비전 필드에서 어떤 일들이 일어나고 있는지, 얘네들이 어떠한 방법으로 트레이닝도 하고 에스티메이트 할 수 있는지를 알아놓는다면은 여러분들에게 도움이 될 거라고 분명히 확신을 합니다. 네. Okay, so this is the end of today's lecture. In the next lecture, we are going to talk about the linear regression and logistic regression, which is the fundamentals of the machine learning. Okay, so thank you. Let's finish today's talk. 그 수업 끝나고 질문하실 분들은 카메라 켜고 뭐 오디오 켜고 해주셔도 되고 아니신 분들은 나가셔도 좋습니다. 수고하셨습니다.